Actually going to start exponent rules, which happens to be my favorite part of this course. For my PJC class, it is going to be 12.1. What we're going to look at is the product rule, power rules for exponents. So the first thing we're going to do is just a couple of examples explaining exponents. And then we have a couple of examples using the product rule. And then we have multiple examples using all of the different power rules. Then we will combine the rules. And then we will actually do at least one problem using geometry and these rules. So if you notice this green table here, I'm going to read this to you. You can get this information out of your book. So this is the summary of definitions and the rules for exponents. What we're looking at right now, and don't get me wrong, this will end up being broken up into multiple different videos. It's just going to have to be. But what we're going to look at first is going to be the product rule. Let me see if I can highlight this, which is that first rule right there. And then we're going to actually look at our power rules, which is all three of those rules right there. In 12.2, what we look at is our zero exponent rule. We will actually look at our negative exponent rule. We will look at our quotient rule, and we will actually combine those rules as well. The negative to positive rules is the same thing as our negative exponent rule. But if you notice here, there's quite a lot of rules. And so it can get very easy to mix these up. I would just recommend watching this video over and over again, doing the homework as often as possible. You are actually supposed to, with the golden rule, study at least 3 hours per semester hour. This is a 3-hour course, which would mean weekly you should be studying at least 9 hours, doing your homework, doing the extra sample examples you can, asking me questions, watching videos, etc. Okay. So let's go and get started. I'm going to just slide up. Like I said, what we're going to start with is looking at some exponents. So I'm going to show you how to actually use exponents. Okay, so what we're going to do here is we're actually going to have two different parts of our exponent. What they are is our base and our exponent. You could see it in the book and in different examples using different variables. Because if you notice, they use a lot of A's and B's and stuff in this section. What I actually want to do is the same thing. How did geometry move? There we go. So let's say we have something raised to something, right? So what we would have here is our A would be our base, and our N here is what you would call an exponent. That's going to be a little n raised up higher than our base. And let's do a few examples real quick. So I'm actually going to, instead of starting with just being like abstract variables, I'm going to show you specifically with some actual numbers. Okay, so let's say for this example, we'll call it example 1. Say we have the number 5, and you would say it's being raised to the 4th power. It's being raised to the exponent of 4. Here, our base is what? 5, that's right. And our exponent would be 4. Okay, so what this is actually saying, it is not saying, let's clear this up, it is not saying 5 times 4. The incorrect answer to this would be 20. What this is actually saying is that you take your base and you multiply your base to itself the number of times the exponent tells you to. So my base here is 5, and I take my base and I multiply it to itself the number of times my exponent tells me to. So if you notice here, I've got an exponent of 4, and so I have 4 5s multiplying each other. Okay, So what we would actually end up getting here is if you do 5 times 5 times 5 times 5, you get 625. If it actually tells you to evaluate your problem or your exponent, the answer would be 625. So this is actually evaluating our answer. If in a problem it asks you to write it in exponential form, that form would be considered exponential form. The reason why it would be called exponential form is because it's in the form that has an exponent. So if you notice, once we get to 625, we no longer have an exponent. We actually solved it based off of what it told us to do. But the exponential form would be keeping the exponent on our base. Okay, so I'd also like to show you this right here. I'm going to scoot up some. If I could get smaller, that might be good. There we go. I'm going to show you this right here. Say what they showed us was a negative 5 raised to the 4th power. So anytime you see a negative sign and you're dealing with exponents, this is where it could get tricky. I want you to notice that this is still similar to problem 1. It's actually the exact same thing. The actual value being raised to the 4th power, or the exponent of 4, is just the number 5. Yes, there is a negative sign right here. And when you evaluate this, you do take that into consideration at the end. Okay, I'm going to do another example, which will show you when is that 5 included with that negative sign. So in this problem, our 5 is being raised to the 4th power. So we would actually have, that's a negative 1, correct? Times our 5, times 5, times 5, times 5. Well, I know 5 times 5 times 5 times 5 was the 625, right? And then if you multiply that by negative 1, don't I just get a negative 625? Correct. And that is because the way it is written, it is our 5 that is the only thing being raised to the 4th power, okay, with the exponent of 4. So, but if you see it like this, y'all, if you see in parentheses, now that whole thing is my base. Does that make sense? That's actually, those parentheses tell you that negative sign is attached to and a part of your base. In the original problem that we did before this, it was right next to it. It was near it. But in math with multiplication, if it's a 1, you usually won't see it. And that was actually a negative 1 times 5 raised to the 4th. 5 with the exponent of 4. The problem 3 is including it all inside of parentheses, which is what tells you, okay, that is my 5 and it is a negative 5. So what you would do here is following just the rule right here. When you look at your exponent, I know that because it's being raised to the 4th exponent, what I'm doing is I'm actually taking negative 5 times negative 5 times negative 5 times negative 5. Well, y'all, 5 times 5 times 5 times 5 is, I keep hitting that button, is 625, correct? Now let's look at our negative signs. A negative times a negative would be a positive. And then a positive times a negative would give me a negative. And then this negative times a negative gives me a positive. So my final answer, I was going to say my ultimate answer, the ultimate answer, the final answer when you do this problem 3 is that you would get a positive 625. So hopefully that kind of makes a lot of sense to you as far as when you have negative signs, be sure that you know, is it included with the base? Is it just next to the base? Will I evaluate it altogether the way I did problem 3? Or will I evaluate it separately the way I did problem 2? Okay, so I'm going to do one more let me see. No, I mean, that should clear it as far as the exponents. If you do have questions about the exponents, make sure you ask me. I feel like this is a decent representation of how you could evaluate it, right, by getting an actual answer, as well as if asked to leave an exponential form. That would probably come in the following few questions, but an exponential form is when you have something and also an exponent. You have a base, whatever your base may be, and you keep the exponent. You don't actually evaluate it. You don't actually do the math, okay? Okay, y'all. So if you have questions, like I said, make sure you ask. I'll be right back to do some more problems. Bye, y'all.